Okay, now today we shall discuss right now about the potentiometer. Okay, and the use of the potentiometer. First use we will discuss. This use is to compare the EMF of two cells. Now the circuit which I have explained in the concept of the potentiometer is as it is. This is the main circuit which is providing the potential difference between point A and C. This battery is utilized for that. Now you want to compare the electromotive force of two cells whose EMFs are E1 and E2. Okay. Now the EMF E1 and E2 is to be compared. Now see, positive terminals of these two cells are connected with the end A of the potentiometer wire, and negative ends of these two cells whose EMF are to be compared, these negative ends are connected with 1 and 2 number terminals of this special key which is known as two-way key. This is a two-way key. And with first and second terminal, you are joining the negative terminal of first cell and second cell. Okay, so second cell is having its negative terminal with the second terminal of two-way key, and the negative terminal of first cell is connected with the first terminal of the two-way key. Okay. The third terminal of two-way key is connected with galvanometer. Okay. The one end of the galvanometer is kept free. Now this end you can take in your hand and you can slide on this potentiometer wire. Okay. And the galvanometer, whenever shows the zero deflection, then we can say that the null point is obtained. To find out the null point on the potentiometer wire, this free end is utilized. Okay, so this is the arrangement of the whole apparatus. Okay, now see, first we want to find out the null point for the first cell. Now why are we finding null point? See, first cell is having electromotive force E1. Okay, and in the concept we saw that we want to make current I, because terminal voltage V is equal to E minus IR. Now if you make this I 0, then this V is equal to E, or V is equal to E will be obtained. Now to make current I 0, this kind of arrangement is made. Now try to understand, whenever two tanks are filled and the level of water is same in both the tanks, and if they are connected from the bottom, then the water will not transfer from one tank to the other tank. It means water current is 0. So whenever same potential points are there in the electrical circuit, try to understand, when the two points are having same potential in the electric circuit, then the current will not flow in the conductor. Okay, so that kind of situation we will try to bring. Now how do we do? First, this 1 and 3 are connected. Then what is the condition? This cell is there in the circuit, or this E1 cell or this battery whose EMF is E1 is connected in the circuit. This cell is not at all present as such right now in this kind of situation. So 1 and 3 are connected. Okay. Now when you take this free end and if you slide somewhere when we go like this, then the galvanometer will show the deflection. It means the current is passing through this cell. Now at certain points, say for example here, at this point, this galvanometer shows zero deflection. What does it do? The current is not passing through E1. Whenever galvanometer shows zero deflection. What does it mean? The current is not passing. If it is passing, then it will show the deflection. So current is not passing when, say, this point is obtained N1, which is nothing but the null point. And we say that from this A to this point L1, the distance between this A and 1 is L1. Okay. So first, what is the condition? 1 and 3 are connected. Jockey is moved on this AC wire and null point N1 is obtained at distance L1 from A. Okay. Now we consider the loop A, N1, G, 3, 1, A, and we apply Kirchhoff rule. Now try to understand. The potential drop between A and N1, potential drop between A and N1, according to our concept of potentiometer, the potential difference between A and N1 will be phi into length of this A N1, and that length we have L1. So potential drop between A and N1 will be phi into L1. Now that potential drop phi into L1 must be equal to the electromotive force of first cell E1. Potential difference between A and N1 is equal to, try to understand, potential difference between A and N1 will be equal to the electromotive force of this cell. Potential difference between A and N1 is equal to the electromotive force of this cell. So the electromotive force of this cell E1 is equal to the potential difference between these 2 points A and N1, and length of this A and 1 is, say, L1, and potential per unit length is phi. So the potential difference between A and N1 will be phi L1. So phi L1 is equal to E1. We can write by just oral calculation, but if you apply Kirchhoff rule in this loop A N1 G 3 1 A, then also the same thing you will get. Loop A N1 G 3 1 A is taken. Now we take the loop A N1 G 3 1 A. So you are moving in this direction, A N1 G 3 1 and A. So you are coming back to the same point. Now see, when you are moving from A to N1, A is a positive terminal and this is negative terminal, so you are moving from positive to negative, because this is, say, is joined with negative, so you are moving to negative terminal, so minus sign you have to take. So minus, then what will you take? What is the potential difference between A and N1? It is phi into L1, because phi is potential difference per unit length, and A and 1 is equal to L1. Say for example we take A and 1 is equal to L1, so L1 into phi, so with negative sign, so minus phi L1 plus, you are having no potential drop across this because zero current is passing through galvanometer, so plus 0. Then you are moving from minus to plus, you have to write plus because you are moving on positive terminal of the battery, so plus E1 is equal to 0, so E1 is equal to phi L1. Similarly, now this connection is removed. This is disconnected. 1 and 3 are disconnected. 2 and 3 are connected now. So what will happen? This will come in the picture, or this battery number 2 will come in the circuit. Okay. So now the terminal, this is taken and moved somewhere on this wire. And say for example you are getting null point somewhere here at N2. Okay, and the distance of this N2 point is L2 from the point A. So AN2 is equal to say L2. Okay, so AN2 is equal to say L2. Okay, now you take the loop. You can take the loop A, N2, G, 3 to A. So A to N2, when you are moving, you are going from positive to negative terminal again. The potential difference between A and N2 will be equal to how much? It will be equal to the potential per unit length, that is phi, multiplied by length of this AN2 wire, that is L2. So phi L2 with negative sign, because you are moving from positive to this terminal that is connected with negative. So minus phi L2 plus 0, there is nothing, and you are passing through this battery from minus to plus. So plus E2 is equal to 0. So E2 is equal to phi L2. Now it is very easy. Take the ratio of this 1 and 2. So E1 upon E2 is equal to phi L1 upon phi L2. Phi will be cancelled out. We will have L1 upon L2. So by taking this ratio of their lengths of their null points, we can compare the electromotive force of first cell to the second cell. If one of the cell is a standard cell, say for example you have this second cell is a standard cell whose electromotive force is known to you, then E1 can be obtained. Okay, just you have to make E1 as a subject of formula. So E1 will be equal to L1 upon L2 multiplied by E2. This value is known to you, say it is a standard cell, then you can even identify the electromotive force of the first cell. Okay, thank you very much.